Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll demonstrate the use of HSR and HSM on this mold part as shown on our screen. The operations that we'll be using on this part include roughing cuts, semi-finished cuts, as well as finished cuts. If we were to open up our first operation, that's HSR operation that we'll be using for the roughing cut. We'll start by using the HM roughing, and the tool that we'll be using will be a 60 millimeter end mill with a 0.8 millimeter radius on the corner. Now let's go down to our passes and we'll note the following. We'll be leaving an offset of 0.5 millimeters on the wall and on the floor, and we'll be stepping down every 3 millimeters. Now, we will also be working with a step over type of HM spiral, which is the best way to work from the outside as well as pocketed areas. Also note that we will be working with a step down type of constant. If we have to take a look at our simulation, you can see that the tool is working from the outside in where it can in those particular areas, and when it gets to the pocketed areas, it'll start working with a pocket type of operation, clearing off the inside, working towards the outside. Now in our next operation, we'll be doing a rest rough operation. We'll be using a bullnose end mill, an 8 millimeter bullnose tool with a 2 millimeter radius on the corner, and if we go down to our passes, this time we'll be stepping down only 1 millimeter to clear off those steps that were left from the previous operation. We'll still, however, be working with a wall offset and a floor offset of 0.5 millimeters. Let's take a look at the simulation, and you'll see that it's working now only in those areas, clearing away the steps that were created by the previous operation, getting it ready now for its semi-finish and finish operations. Now we'll start off with our first semi-finish operation in HSM using constant Z, and we'll use it only in steep areas. The tool that we'll be using will be a 10 millimeter ball end mill, and if we go into our passes, you'll note that we'll be leaving a wall offset of 0.25 millimeters, getting it ready for the finish cut. And we'll also be working of angles between 40 and 90 degrees. This will only work in the steep areas, so anything less than 40 degrees, it'll not work in those areas. Let's take a look at the simulation. You'll see that it's only working on the steep areas on the part itself. Anything that's not steep, it'll not work in those areas. As we go along, you'll see as it goes around the part, it's only working in those steep areas. The areas that are not steep will be done then later on in our next semi-finish operation. Now in our next operation, we'll again be doing a semi-finish operation, but this time we'll be working in the shallow areas. So to work in the shallow area, we'll be using the option of linear machining. Again, we'll be using the same end we used last time, and in our passes, we'll be doing it again at a wall offset of 0.25 millimeters. This time, however, we've limited our angles between 0 and 42 degrees. This will keep it down to its shallow areas. Now, since last time in our constant Z, we work between 40 and 90, so we have this set at 42, so that way we have a 2-degree lap over between the two operations. Let's take a look at the simulation itself, and you'll see that this time it'll only be working in the shallow areas. Areas such as these floors over here will not be worked on. Notice again, the shallow areas are being worked on, but none of these areas will be touched at all, as this is more than 42 degrees. So this will actually complete the operation from what the previous operation was limited from doing. In our next operation, we'll be doing a rest machining on the corners to relieve any of the excess material we have on the corners, to make it a lot easier for when we work on the finishing cuts. And again, we'll be doing this with as a semi-finish operation. If we were to open up the operation, you'll see that we'll be using the option of rest machining. The end mill that I will be using will be a ball nose mill of 6 millimeters, and our reference tool will be of 16 millimeter diameter with a 8 millimeter corner radius. This is a virtual tool telling exactly where we want the other tool to work within those boundaries. Again, if we take a look in our passes, you'll know we'll be leaving an offset of 0.25 millimeters on the wall and on the floor. If we take a quick look at the simulation, you'll see that the end mill will only work on those corners. Wherever we have a fillet in those areas, those are the only areas where this particular tool will work. Clearing it away so that when we do a finish cut, there will be a lot less stress on the tool that has to work there later on. Now, in the rest of our operations, we'll be doing finish cuts. We'll be doing actually the exact same operations that we did before, but this time going all the way to the final surface. If we were to open up the first of them, we'll be using again the constant Z to work on the steep areas. In our geometry, you'll also note that we're applying a fillet to the corners, this way to avoid any sharp turns inside the corner. The tool will be an 8 millimeter ball end mill, and if we go into our passes, you'll note that we're working with an offset of 0 both on the wall and floor so that we get to the finished surface. We'll be working with a step down of 0.2 millimeters to get a nice smooth surface, and since we're working on the steep areas, we're limiting our angle of engagement between 40 and 90 degrees on the part itself. If we were to take a look at the simulation, you'll see that the end mill will be working only on the steep areas. All the shallow areas, such as these areas over here and these areas over here, will not be worked on as they are less than 40 degrees. Now, we'll be doing a linear cut in our next operation to finish off all the shallow areas that were on the part. So if I were to open up the operation, we'll be using the linear machining as we did just before, but this time as a finish cut. Again, we'll be doing apply fillet so that we do not have any sharp turns in any of the corners. And if I were to go into my tool, you'll note I'll again be using the 8 millimeter ball end mill. In my passes, you'll also see that my wall and floor offset are set as 0 as I'm going to the finish cut, and we'll be doing a step over of 0.3 millimeters to get a nice smooth finish. Also, since we're working in the shallow areas, so I am limiting my working area to work anywhere between 40 and 42 degrees. Anything above 42 degrees is not shallow, so therefore it will not work in those areas. If I have to take a look at the simulation, you'll see that the tool will work only on the shallow areas. Note these areas over here, the steep areas, will not be worked on, as well as the ones on the sides over here. Only the steep areas were cut. In the next operation, we'll be doing a rest machining now to finish off all the corners. If we have to go into the operation itself, we'll be using, as I said, the rest machining option, and the tool that we'll be using will be a 4 millimeter ball end mill. This time we'll be going, however, to the finish cut. Before we did this going to the semi-finish, now we'll be doing the finish cut. The reference tool will be a 12 millimeter 6 ball end mill, and this will actually determine where the present tool will work. In the passes, you'll see that our wall and floor offset is set to 0, making it ready for the finish cut. If we take a look at the simulation, you'll see that the tool will work exactly in those corners and only in those corners for finish off all those cornered radiuses as we see over here, making for a nice smooth finish. Now for our last operation, I'd like to put actually a small little chamfer on this edge over here, and to do that we've used the option of HSM boundary. If I were to open up the operation, you can see we'll be using boundary machining. The tool that I will be using will be a 10mm chamfer drill, and if we go into our drive boundaries, I've chosen to make the boundaries automatically around the box of the part, giving it a 2mm offset. If we take a look at the actual boundary itself, you see that the offset is 2mm, so the center of the tool will actually be traveling on this line. Now if I go into my passes, you'll see that I've added also a floor offset of minus 0.2mm. By giving it a negative floor offset, I'm allowing the tool to actually gouge into the part, giving it that chamfer that I need. If I were to run the simulation, you'll see that the tool goes around the part, giving for a nice chamfer on all of the edges. For more videos on SolidCAM Professor, please go to our website www.solidcam.com and look for our Professor tab. Take care and have a nice day.